Amazon Web Services is definitely one of the most popular cloud platforms which houses a collection of cloud computing services. And also it opens up different career prospects in the world of cloud computing. And if we go by the stats, it is definitely one of the most demanding technologies right now. Hi everyone, in today's session we will discuss some of the most commonly asked AWS Solution Architect interview questions, and we will understand what are the kind of questions that you have to go through if you are attending any such interview. Also, it will definitely help you start your career and also have an idea of what and all you should prepare for your AWS interviews. So let's get started. Now, the first question is a very common one, that is, what is Amazon EC2? Now, EC2 is basically the short for Elastic Compute Cloud, and it provides scalable computing capacity. Using Amazon EC2 eliminates the need to invest in hardware, leading to faster development and deployment of applications. You can also use the Amazon EC2 to launch as many or as few virtual servers as needed, configure security and networking, and also manage storage. It can scale up or down to handle changes in requirements, reducing the need to forecast traffic. Now, the EC2 provides virtual computing environments which are called as instances. So this was about the Amazon EC2. Now moving on to the next question. What type of performance can you expect from Elastic Block Storage, which is also known as the EBS? So how do you back it up and enhance the performance? Now, for the performance of an Elastic Block Storage varies, that is, it can go above the SLA performance level and also after that drop below it. Now, SLA provides an average disk I/O rate, which can at times frustrate performance experts who yearn for reliable and consistent disk throughout on a server. Now, virtual AWS instances do not behave this way. One can back up EBS volumes through a graphical user interface like the Elastic Fox, or use the snapshot facility through an API call. Also, the performance can be improved by using Linux software RAID and striping across 4 volumes. The next question is how terminating and stopping an instance are the different processes. Now, the instance performs a regular shutdown when it is stopped. It then performs transactions as the entire EBS volumes remain present. It is possible to start the instance anytime again when you want. The best thing is when the instance remains in the stop state, users don't need to pay for that particular time. But when it comes to termination, the instance performs a regular shutdown. And after this, the Amazon EBS, that is the Elastic Block Storage volumes, start deleting. So you can stop them from deleting simply by setting the delete on termination to false. Because the instance gets deleted, it is not possible to run it again in the future. So this is how these two processes, that is the termination and the stopping, are different. Now moving on to the next question, what are the differences between an on-demand instance and a spot instance? Now, spot instance is similar to bidding, and the price of bidding is known as the spot price. Both spot and on-demand instances are pricing models. In both of them, there is no commitment to the exact time from the user end without upfront payment. Spot instance can be used while the same is not possible in case of an on-demand instance. It needs to be purchased first and the price is higher than the spot instance. Now, the spot instances are spare unused EC2 instances which one can bid for, and once the bid exceeds the existing spot price, the spot instance will be launched. If the spot price becomes more than the bid price, then the instance can go away anytime and terminated within 2 minutes of notice. Now, the best way to decide on the optimal bid price for a spot instance is to check the price history of last 90 days that is available on AWS console. Now, the advantage of spot instances is that they are cost effective, and the drawback is that they can be terminated anytime. And mostly, spot instances are ideal to use when there are optional nice to have tasks, you have flexible workloads which can be run when there is enough compute capacity, tasks that require extra computing capacity to improve performance. Talking about the on-demand instances, these are made available whenever you require them, and you need to pay for the time you use them only on an hourly basis. These instances can be released when they are no longer required and do not require any upfront commitment. The availability for these instances is guaranteed by AWS, unlike spot instances. So these were some of the differences between the spot instance and also the on-demand instance. Now the next question is, how do we vertically scale on an Amazon instance? Now, in order to vertically scale on an Amazon instance, we need to follow certain rules. So the first one is you have to spin up a larger Amazon instance than the existing one. Also, pause the existing instance to remove the root EBS volume from the server and discard. Then you have to stop the live running instance and detach its root volume. Also, make a note of the unique device ID and attach that root volume to the new server. Finally, you have to just start the instance again. So these are the steps that you need to follow in order to vertically scale on an Amazon instance. Now the next question is, what is the difference between a vertical and a horizontal scaling in AWS? Now the main difference between vertical and horizontal scaling is the way in which you add compute resources to your infrastructure. In vertical scaling, more power is added to the existing machine, while in horizontal scaling, additional resources are added into the system with the addition of more machines into the network so that the workload and processing is shared among multiple devices. Now, the best way to understand the difference is imagine that you are retiring your Toyota and buying a Ferrari because you need more horsepower. This is vertical scaling. Now, another way to get that added horsepower is not to ditch the Toyota for the Ferrari, but buy another car. This can be related to horizontal scaling where you drive several cars all at once. So when the users are up to 100, an EC2 instance alone is enough to run the entire web application or the database until the traffic ramps up. Under such circumstances, when the traffic ramps up, it is better to scale vertically by increasing the capacity of the EC2 instance to meet the increasing demands of the application. AWS supports instances up to 128 virtual cores or 488 GB RAM. Now, when the users for your application grow up to 1,000 or more, vertical cannot handle requests and there is need for horizontal scaling, which is achieved through distributed file system clustering and load balancing. So I hope you have understood the difference between a vertical and a horizontal scaling. Now let's move on to the next question, that is, when instances are launched in the cluster placement group, what are the network performance parameters that can be expected? Now, this basically depends largely on the type of instance as well as on the specification of network performance. Now, in case they are started in the placement group, you can expect parameters like 20 Gbps in case of full duplex or when in multi-flow. And then you will have up to 10 Gbps in case of a single flow. And finally, outside the group, the traffic is limited to only 5 Gbps. Now, moving to the next question, what is Amazon Virtual Private Cloud or VPC and why is it used? Now, a VPC is the best way of connecting to your cloud resources from your own data center. So once you connect your data center to the VPC in which your instances are present, each instance is assigned a private IP address that can be accessed from your data center. That way you can access your public cloud resources as if they were on your own private network. So this is exactly why mostly we use the VPC, because you can access your resources and make it your own private network as well. Now the next question is, what are the states available in processor state control? Now there are two states that are available, which is the P state and also the C state. Now P state has different levels starting from P0 to P50. Whereas when you come to the C state, its levels are from C0 to C6, where C6 is the strongest state for the processor. So these are the two basic and main states that are available and that you can use. Now let's have a look at the next question. So how do we transfer the existing domain name registration to Amazon Route 53 without disrupting the existing web traffic? Now for this, you will need to get a list of the DNS record data for the domain name first. It is generally available in the form of a zone file that you can get from your existing DNS provider. Now, once you receive this DNS record data, you can use Route 53's management console or simple web services interface to create a hosted zone that will store your DNS records for your domain name and follow its transfer process. It also includes steps such as updating the name servers for your domain name to the ones associated with your hosted zone. For completing the process, you have to contact the registrar with whom you registered your domain name and follow the transfer process. As soon as your registrar propagates the new name server delegations, your DNS queries will also start to get answered. So this was about the transferring the existing domain name registration to Amazon Route 53, and there would be no disruptions this way. Now let's have a look at the next question, which is how is AWS Elastic Beanstalk different than AWS OpsWorks? Now AWS Elastic Beanstalk is an application management platform, while the OpsWorks is a configuration management platform. Now, Beanstalk is an easy-to-use service which is used for deploying and scaling web applications developed with Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. Now, customers upload their code and Elastic Beanstalk automatically handles the deployment. The application will be ready to use without any infrastructure or resource configuration. But when we talk about the AWS OpsWorks, it's an integrated configuration management platform for IT administrators or DevOps engineers who want a high degree of customization and control over operations. So I hope you have understood how the Elastic Beanstalk is different from the AWS OpsWorks. Now moving on to the next question, what happens if the application stops responding to requests in a Beanstalk? Now, AWS Beanstalk applications have a system in place for avoiding failures in the underlying infrastructure. If an Amazon EC2 instance fails for any reason, Beanstalk will use auto-scaling to automatically launch a new instance. So Beanstalk can also detect if your application is not responding on the custom link. Even though the infrastructure appears healthy, it will be logged as an environmental event. For example, a bad version was deployed, so you can take an appropriate action here. So basically, you just have to use the auto-scaling for an automatic launch of the new instance. Now the next question is, an organization wants to deploy a two-tier web applications on AWS. The application requires complex query processing and table joins. However, the company has limited resources and requires high availability, which is the best configuration that company can opt for based on the requirements. So if we talk about the best configuration, DynamoDB deals with core problems of database scalability, management, reliability, and performance, but does not have the functionalities of a RDBMS. Now, DynamoDB does not render support for complex joins or query processing or complex transactions. So you can run a relational engine on Amazon RDS or EC2 for this kind of a functionality. So I guess here DynamoDB is the best configuration that the company can opt for based on all of these requirements. Now talking about the next question, how can you safeguard EC2 instances running on a VPC? Now, AWS security groups associated with EC2 instances can help you safeguard EC2 instances running in a VPC by providing security at the protocol and port access level. So you can configure both the inbound and outbound traffic to enable secure access for the EC2 instance. AWS security groups are much similar to a firewall. They contain a set of rules which filter the traffic coming into and out of an EC2 instance and deny any kind of unauthorized access to EC2 instances. So this is exactly how you can safeguard all your EC2 instances running on a VPC. Next is, what automation tools can you use to spin up the servers? Now there are different tools that can be used here. So first you can have the roll your own scripts and use the AWS API tools. Such scripts could be written in Bash, Perl, or other language of your choice. And then you can also use a configuration management and provisioning tool like Puppet or its successor OpsCode Chef. You can also use a tool like the Scalar and use a managed solution such as the RightScale. Now moving on, what are some of the important features of a classic load balancer in EC2? Now, the high availability feature ensures that the traffic is distributed among EC2 instances in single or multiple availability zones. This ensures high scale of availability for incoming traffic. Now, the classic load balancer can decide whether to route the traffic or not based on the results of health check. So you can implement secure load balancing within a network by creating security groups in a VPC. And finally, there's this classic load balancer which supports sticky sessions, which ensure that the traffic from a user is always routed to the same instance for a seamless experience. These are basically some of the important features of a classic load balancer in EC2 and how it actually helps you whenever you're using this. Now let's move on. So what do we know about an AMI? So AMI is basically considered as the template for the virtual machines. While starting an instance, it is possible to select the pre-baked AMIs that AMI commonly have in them. However, not all AMIs are available to use free of cost. It is also possible to have a customized AMI, and the most common reason to use the same is nothing but saving the space on Amazon Web Service. This is done in case a group of software is not required and AMI can simply be customized in that particular situation. So this was all about AMI in AWS. Now, what is the total number of buckets that can be created in AWS by default? Now, this is a very simple question, but is also one of the most asked questions. So you can have 100 buckets that can be created in each of the AWS accounts. And if you need additional buckets, then you have to increase the bucket limit by submitting a service limit increase. But basically, you can just have 100 buckets for each AWS account. Now next is explain stopping, starting and terminating an Amazon EC2 instance. Now stopping and starting an instance are the most common commands used on the Amazon EC2 platform. And these are definitely one of the most asked questions in any AWS interview as well. Now once the command for stopping an instance is used, the instance first performs a normal shutdown and then transitions itself to a stopped state. All the Amazon EBS volumes remained attached as they were, and you can resume the instance at a larger state. One of the main advantages of this feature is that Amazon does not charge you additionally for the hours while the instance was in a stopped state. So when you issue the termination command to an instance, the instance first performs a normal shutdown and then moves ahead with detaching the existing Amazon EBS volumes. This can only be achieved if the delete on termination attribute is set to false in the Amazon EBS settings. Now, once it is terminated, the client cannot resume the instance at a later stage. So this was all about stopping, starting, and also terminating any Amazon EC2 instance. Now, moving on to the next question, how can S3 be cast off with EC2 instances? Now, it is possible to cast off with EC2 instances by using root approaches, which have the backup of native occurrence storage. So when a developer or a client is using Amazon S3 services, they have the capability to use extremely scalable and additionally fast, dependable, low-priced data storage structures that are used by Amazon itself to track the worldwide network of its own websites. However, in order to perform these operations in the Amazon EC2 atmosphere, developers need to use certain tools in order to load their Amazon machine images or the AMIs into Amazon S3 and then transfer them back to Amazon EC2. Now, the additional use of this method might be when developers need to load stationary content into S3 from their websites hosted on Amazon EC2. Now let's move on to the next question. Now the next question is list out the different ways to access EC2. Now EC2 can be accessed both via web-based interface and also command line interface. Additionally, there are PowerShell tools available in Windows which can be simply executed. Now the next question is to define regions and availability zones in Amazon EC2. Now, being such a mammoth in the industry, it is common knowledge that Amazon EC2 will be hosted in multiple locations across the world. These worldwide locations are categorized in terms of availability zones as well as regions. Now, each of these regions is completely independent of the other, and each availability zone is isolated as well. But all the availability zones in a particular region are interconnected through multiple low latency links. So this was about the regions and also the availability zones in Amazon EC2. Now moving on to the next question, what is Amazon EC2 root device volume? Now when you as a developer launch an instance, the root device volume has the image that was used to boot up the instance in the first place. Now there are two types of AMIs or Amazon machine images that are available. First we have the EBS based storage, that is Elastic Block Storage, and then we have the instance store back AMI. So this is what Amazon EC2 root device volume is all about, and also the two types of AMIs available. Now next up, what is auto scaling and also how does it work? So auto scaling is one of the most important features that Amazon Web Service provides that gives you an allowance to configure and automatically stipulate and also twists new instances without even your intervention. Now this can be done by setting the edges and measurements to screen. At the point when those edges have crossed, another instance based on your preference will be spun up, rolled, and configured into the load balancer pool. Now you would have scaled that horizontally without the intervention of an operator. So this is exactly how the auto scaling works. And you can see that you will have either a minimum size, then have a desired capacity, scaled out as needed, and also finally the maximum size. So you can consider what is the minimum size based on the least number of size of any particular block. Then you can also specify your desired capacity of how much you want it to be. Then scale out as needed. You can scale out the extra part, and also you can include the entire size or the maximum size. Now next up, what is server load balancing? So once you're connected to the internet, you will have a load balancer which will be applied to all your application web servers and which will directly go to your database. Now this SLB or the server load balancing provides the performance of the network, and also it delivers the content by the implementation of a series of priorities as well as algorithms, which helps in responding to the precise requests that are made to the network. In other words, server load balancing takes the part of distributing the clients to a vast group of some servers, and that also ensures that the clients which are sent are only sent to the specific servers and not to the failed servers. Now the next question is, what is global server load balancing, and does clustering need to be turned on in order to use the GSLB or the global server load balancing? Now the GSLB or the global server load balancing is very much similar to SLB, which is the server load balancing. But GSLB takes SLB to a global scale. It authenticates us to stack balance VIPs from various geographical locations as well as a single entity. From this, the geographic site gets scalability and also fault tolerance. Now you must turn on clustering and also configure it in order to use the global server load balancing. Each and every proxy that comes within the site or cluster must acquire the same configuration. So every piece of equipment can act as a DNS server if that becomes the master for the site. And each of the sites will be having a unique SLB or GSLB or cluster configuration, and you will have to use the GSLB site overflow command so that the remote GSLB site can be added to the local appliance. Moving on, the next question is, what are those load balancing methods which are supported with Array Network GSLB? Now there are different methods of the global server load balancing that are supported by the Array appliance. So we have three methods. First is the overflow, then we have LC and RR. Now for overflow, this method allows all the requests to be sent to the different remote site when the local site ID loaded up to 80%. Now next is the LC. So LC basically stands for the least connections. It sends the clients to the site which has the least count of current connections. And next we have the RR, which stands for the round robin, and it sends the clients in the round robin suction to each site. So these were the different load balancing methods supported with the Array Network GSLB. Now moving on, what is reverse proxy cache? Now reverse proxy cache is a cache that is presented in the front of the origin servers. That's the reason for using the reverse term in the name. And if a request of the cached object is made by the client, then the request will be served from the cache and not from the origin server by the proxy. So this is what happens in case of any reverse proxy cache. Now next is mention some of the advantages of AWS Elastic Beanstalk. Now there are many advantages for the AWS Elastic Beanstalk. Talking about some, the EBS is economical with no hidden costs and you will pay for whatever you use, not for anything extra. So not more, not less. Now the AWS Management Console can be accessed within an hour with its fast access. So it wouldn't take much time. It will just take an hour for you to get the Management Console. Then it also supports languages like Java, .NET, PHP, Node.js, Python, Ruby, etc. And finally, AWS EBS builds the setup and spectators the AWS service for the creation of web services. Now the next question is define automate deployment. Now the automate deployment method is very similar in many ways to programming in other languages. However, the unique advantages of this platform is that it helps in cutting down a lot of challenges. Now, one of the best things is the deployment can be made as one becomes more proficient with other offerings of the service. Using automated deployment, clients can minimize human interference and also ensure that the outcomes are quality-based in every aspect. Next up, what are the advantages of using the serverless approach? Now, using the serverless approach has multiple advantages. So talking about some, the approach is utterly simple, which converts to quicker time to market and thus higher sales. Clients are also only required to pay when the code is in operation. Thus, a huge amount of money can be saved in enhanced profits. And also, clients do not need any additional infrastructure in order to run this application. And they also do not need to give any second thought on the server which is running the code. So these are some of the advantages of using the serverless approach. Now moving on, what is the Amazon Cloudwatch? Now Amazon Cloudwatch is basically a management tool. It is a part of the Amazon Web Services family. It is basically a monitoring service for AWS cloud resources and all applications run on the AWS platform. Cloudwatch can also be used to track and collect metrics, set alarms, collect and monitor log files, and also monitor resources such as EC2 instances, RDS-DB instances, and DynamoDB tails. So now that you know what is the Amazon Cloudwatch, what else can be done with this Cloudwatch logs? So as Cloudwatch is capable of storing and monitoring a client's logs and help them better understand how their systems and applications are operating, Cloudwatch can be used to log in multiple ways, like the long-term log retention and also the real-time application and system monitoring. So these are basically the two ways of using the Cloudwatch logs. Now, next question is which platforms support Cloudwatch logs agent? Now, the Cloudwatch logs agent is supported by a number of operating systems and platforms. So we have the CentOS, Amazon Linux, Ubuntu, Red Hat, Enterprise Linux, Windows. Basically, all of these support the Cloudwatch logs agent. And there are many more which also supports the same. And that's exactly why the Cloudwatch logs is so popular and also easy to use. Now moving on, list out the retention period of all metrics. Now Cloudwatch retains all its metrics differently. So for example, any data points or high-resolution custom metrics with a span of fewer than 60 seconds are available for 3 hours. Then we also have the data points with a period of 60 seconds which are available for 50 days. Then data points with a period of 5 minutes are available for 63 days. Also, data points with a period of 1 hour are available for 455 days or 15 months. So these are some of the metrics of the retention period. Now moving on to the next question, what are some of the key best practices for security in Amazon EC2? Now, some of the best practices include creating individual IAM, that is the Identity and Access Management, users to control access to your AWS resources. Now, creating separate IAM user provides separate credentials for every user, making it possible to assign different permissions to each user based on the access requirements. Also, it secures the AWS root account and its access keys. Then you can also harden the EC2 instances by disabling unnecessary services and applications by installing only necessary software and tools on EC2 instances. Then you can grant least privileges by opening up permissions that are required to perform a specific task and not more than that. Additional permissions can also be granted as required. You can also define and review the security group rules on a regular basis and have a well-defined strong password policy for all the users. Finally, you can deploy the antivirus software on the AWS network to protect it from Trojans, viruses, etc. So these were some of the best practices for security in Amazon EC2. Now moving on. Now, there is a distributed application that processes huge amounts of data across various EC2 instances. Application is designed in such a way that it can recover gracefully from EC2 instance failures. So how will you accomplish this in a cost-effective manner? Now, on-demand or reserved instance will not be idle in this case, as the task here is not continuous. Moreover, it does not make sense to launch an on-demand instance whenever work comes up, because on-demand instances are expensive. In this case, the ideal choice would be to opt for a spot instance owing to its cost-effectiveness and no long-term commitments. Now, the next question is, what are the important features of a classic load balancer in EC2? Now, talking about the important features of a classic load balancer in EC2, there's the high availability feature, which ensures that the traffic is distributed among EC2 instances in single or multiple availability zones. This also ensures high scale of availability for incoming traffic. Now, classic load balancer can decide whether to route the traffic or not based on the results of health check. You can also implement secure load balancing within a network by creating security groups in a VPC. And then classic load balancer supports sticky sessions, which ensure that the traffic from a user is always routed to the same instance for a seamless experience. So these were the important features of a classic load balancer in EC2. Now moving on, what are the possible connection issues you encounter when connecting to an EC2 instance? So there are many issues that one might face, but some of the most common ones are the unprotected private key file. Then there might be the server refused key, and also connection timed out, which happens mostly because you have not logged in for quite a long time. So you can have a connection timed out issue here. Then no supported authentication method available. Another issue that you might encounter is the host key is not found and permission is denied. Also, user key is not recognized by the server and the permission has been denied. So these are just some of the common issues that everybody encounters while connecting to any EC2 instance. Now moving on, mention the time span in which the AWS Lambda function will execute. Now all the process of AWS Lambda and execution takes place within 300 seconds from placing calls to AWS Lambda. Now the default timeout is 3 seconds rest. You can set up any value between 1 to 300 seconds. So basically we are saying here that the default timeout is 3 seconds, and after that you can set up any value, but the maximum limit is anyway 300 seconds. Now moving on, mention the role of SQS in Lambda. Now there is a certain approach which is used for sharing of information and passing that information among different hosts and connectors, and communication can be established. The functional components should be connected even if they are different. Now there are many advantages of using SQS, and several of the failures are also eliminated with the help of SQS in Lambda. The next question is, what are the final variables? Now once assigned, these variables cannot be changed. In its earlier stage, they are known as effective variables, where any form of change is possible and the values are assigned to them. They also play an important role in testing, and most of the local expressions are final. Moving on to the next question. A company needs to monitor the read and write IOPS for their AWS MySQL RDS instance and send real-time alerts to their operations team. So which AWS service would be able to accomplish this? Talking about the different services that we have in AWS, like the Amazon Simple Email Service, Cloudwatch, Amazon Simple Queue Service, and Route 53, here we can go for the Amazon Cloudwatch. Now, this is a cloud monitoring tool, and hence this is the right service for the mentioned use case. Now, the other services can be used for other purposes, like you can use the Route 53 for DNS services. Thus, for this particular case, you should opt for Cloudwatch service in Amazon. And this will be the apt choice. Now, the next question is, what is configuration management? Why would you want to use it with cloud provisioning of resources? Now, configuration authority has been throughout for prolonged period in network services and systems control. Yet, the rising reputation of it has been confined. Maximum systems managers configure computers as the software was improved before version controller, that is manually performing modifications on servers. Every server can later and customarily be modified. Now, troubleshooting, though, is outspoken as you log into the case and work on it instantly. Configuration authority delivers massive computerization equipment into the picture. Managing servers similar twines of a puppet, this drives regularity, excellent works, and reproducibility as all configs are maintained and versioned. It also proposes a distinct way of operating, which is the huge barrier to its adoption. Now, join the cloud and configuration administration becomes equivalent major critical. That's because pragmatic servers such as Amazon's EC2 instances are enormously limited reliable than physical ones. You surely need a tool to reconstruct them as at any consequence. This promotes vigorous practices like computerization, reproducibility, and failure restoration into the internal frame. Now, next up, the final question here is, what is AWS Certificate Manager? Now, AWS Certificate Manager, or the ACM, manages the complexity of extending, provisioning, and regulating certificates granted over ACM to your AWS-based websites and forms. You work ACM to petition and maintain the certificate and later practice other AWS services to provision the ACM certificate for your website or purpose. As designated in the subsequent instance, ACM certificates are currently ready for a performance with only Elastic Load Balancing and Amazon CloudFront. You cannot handle ACM certificates outside of AWS. So these were some of the most frequently asked questions during any AWS Solution Architect interviews, and these are all the advanced level questions. And with this, we have come to the end of today's session as well. And if you have gone through any other questions that are frequently asked in the interviews, and if you have attended any such interviews where you have found new questions, you can put that up in the comment section below and also share your opinion regarding today's session. Till then, thank you and happy learning.